Okay, if you're in Chem 20 right now, an important part of the first unit, your bonding unit, is understanding VSEPR. So just going through a few examples, starting with knowing that when you're looking at VSEPR theory, this only applies to molecular compounds because that's what shares electrons. Ionic compounds doesn't exchange and always form a crystal lattice. So when you're looking at the bonding unit, usually you spend maybe 1 day reviewing ionic compounds, and then the rest of the unit is showing molecular and how we look at how it's bonded. So when you're looking at VSEPR, what it is, it's valence shell electron pair repulsion theory. And it is talking about how you arrange your atoms or you arrange your other atoms around the central, you leaving electron pairs as far as possible as it can be, because they'll start to repel each other. When we're looking at this, it really does depend on the central molecule, your bonding pairs, and your lone pairs. So we do want to know what that means when we're looking at it. There are some steps to follow if you're ever stuck. The first one, you count your total number of valence electrons, then you draw your Lewis dot diagram, place them around the central molecule, and then add in the others. You want to count lone pairs and your bonding pairs. I really only follow these steps when I can't figure it out, like if it's a more complicated molecule. Usually you can just get there based on that Lewis structure. The point of getting that AXE formula is that AXE formula, depending on the number that we have for M and N, will give us a direct shape. And as long as we know the AXE formula and the shape, we'll always be able to draw what's happening. So here's an example with carbon dioxide. So we have the total number of valence electrons. We draw out the Lewis dot diagram, adding in some double bonds or moving electrons to form double bonds. And then knowing that from the formula, your central atom is carbon, which is shown by A. Your X is your bonding atoms, and there's 2 of them. So that would be X2. And in this case, there's no lone pairs. So we don't have the E on the end because the lone pairs only apply to the central atom. So we don't have any. Unlike these lone pairs on oxygen, but because those are peripheral atoms, we don't count them. So there's no E here. So when we look at shapes, we're looking for that AX2 shape. Every AX2 shape will be linear. Linear meaning you're in a straight line. If you have a simplified version and it's AX3, that's trigonal planar. Trigonal planar always will have those equal distances between the bonds, keeping all those electrons as far as possible that you can get. CH4 is an AX4 shape, and that's tetrahedral. Now we're getting a little bit more complicated because we have a 3D shape that we're trying to draw on a 2D plane. So you'll have to start using this in the page, out of the page, where you have 1 bolded line and 1 dotted line. Our second last one is AX3E, which gives you trigonal pyramidal. So when you show this, you do show lone pairs on your central atom because it does affect the shape, and it will push the other bonds down. So these bonds are a little bit closer together because of that. And then we still need to show that 3D shape using that in the page, out of the page. Our last one is an AX2E2 shape. This is called V-shaped or bent. When we're looking at it, because those lone pairs, those 2 lone pairs are on the central atom, you show it. And in real life, if you're looking at the 3D shape, those lone pairs take up so much more space that they push the other 2 atoms down, and that's what creates that V shape. Now, when you're going through it and we're following those steps, and again, I'm going to follow them loosely unless I get stuck. Then I'll follow steps 1 through 5 more seriously. So our first one, nitrogen trioxide, would be Ni3. Total valence electrons, nitrogen comes with 5. Iodine comes with 7, but there's 3 of them. So we have 26 valence electrons to place. Now, usually it's the atom that is different that goes in the middle, or the one that can bond to the most other atoms. So in this case, it's nitrogen. And when you place the 5 valence electrons around nitrogen, then we can add an iodine because nitrogen can bond to 3 other items, and we have 3 iodines to place, all coming in with 7 electrons. So now we have our Lewis dot diagram. Your formula describing nitrogen would be A, which would be the nitrogen, X3, which would be the iodines, and 1E because of the lone pairs on top. So this shape is your trigonal pyramidal. And when you're drawing it out, we do show lone pairs on your central atom. And then because we need that 3D shape, we need one bolded line and one dotted line. And then just add in your iodines. So now we have the stereochemical formula, and that's just another more complicated way to say your VSEPR drawing. Our next one, NO positive. NO positive brings in 5 nitrogens. Oxygen comes with 6, so that's a total of 11. To have a charge that's positive, you lost 1 electron. So we have actually 10 electrons we're going to place. So nitrogen still comes with 5. Oxygen comes with 6, but because we've lost 1, we only have 5 more electrons to place. So we do that. There's 2 up here. And then we need to move some electrons. So like these 2 can go in the middle. These 2 can come in the middle. So now we have nitrogen with a lone pair, triple bonded to oxygen with a lone pair. With the shape, this is an AXE formula, and it's going to be linear. Now, it wouldn't matter which one I picked to be my central atom because it has the same formula and the same shape. If your molecules are symmetrical, just pick one. If they're not, then describe what's happening around each of them. So then when I go to draw this out to show that it's linear, it's just attached to each other. There's nothing more we have to fill in. N2 would be nitrogen gas. Actually, I need to go back to the other one for a moment. Because it's an ion, we should have our brackets and show that it is charged with that positive value. Okay, now we'll move on. So nitrogen gas each come with 5, so that's a total of 10. So this is similar to this last one because nitrogen is bonded to itself, each of them coming with 5, moving around those electrons to come into the middle. It's exactly like the previous one with that triple bond. And then describing it again, it's an AXE shape and it's linear. Now, anytime you're only bonding 2 atoms, it will always be linear. So we don't really have to do this each time, but it is helpful just to get in the habit of coming up with that AXE formula and recognizing shapes. So this one was an example, but we'll do it one more time just to make sure we understand it. So carbon dioxide is the name. Carbon comes with 4 valence electrons. Oxygen comes with 6, and there's 2 of them. So that would be 12 plus 4 is 16. Wow, that was hard for me. So carbon in the middle coming with 4. So carbon likes to be in the middle, also because it can bond to the most other amount of atoms, which is 4. Oxygens will go on each side, making it symmetrical, and they come with 6. So 1, 2, 3, 4, 5, 6, and then same on the other side. 1, 2, 3, 4, 5, 6. And now we're going to take these unbonded electrons and move them in the middle. And then these 2 unbonded, move them in the middle. So when you're describing that middle one, you have an AX2 shape with no lone pairs. This is also going to be linear, and you're drawing that out. It will look like this. And now I do see sometimes where you will see the double bond in the VSEPR diagram or the stereochemical formula, and other times you'll see it just with one thick line representing those 2 bonds. So I have seen it both ways. If you are in Chem 20, you might want to ask your teacher which way they test you on. Then we have ethane. If you're unsure of what ethane is, take a look at page 4 or 5 of your data booklet, and then you'll see that it's C2H6. We're still doing the same thing, getting the total. So carbon's still coming with 4 electrons, but there's 2 of them. Hydrogen comes with 1, and there's 6 of them. So we have 8 plus 4, 14, 8 plus 6 is 14, so 14 to show. Now, carbons, again, they like to be in the middle, and if there's more than one, they are usually attached together, and you will get into a habit of this. And then if there's any other atoms, the 2 carbons will share them equally. In this case, there's 6, and luckily there's 6 to place, so we're just going to add in all of those hydrogens. And now again, in this case, you have 2 central atoms, each of those carbons, but because it's symmetrical, if I was to describe them, each carbon has an AX4 shape. So if there was a different shape around the second one, I would describe it too, but because there's the same, I just write it down once. So each carbon will have a tetrahedral shape. So when you go to draw it, so carbon 1, we need two solid lines, a bolded line, and a dotted line, showing that 3D shape. And that carbon is attached to another carbon. So we'll fill that one in first, and then it has hydrogens. Now this second carbon also has a tetrahedral shape. So it also will need, and it already has one solid line. So we need one more bolded line, and one more dotted. And then fill in your hydrogens and you'll be done. Chlorine gas is Cl2. Chlorine comes with 7 valence electrons. There are 2 of them, so 14 altogether. Drawing that out, we have chlorine with 7 valence electrons. Add in another one, 7 valence electrons. Once again, that's chlorine. It's an AX shape, right? Chlorine being the central, X, and then you can even add E3 because they have that 3 lone pairs on it. But again, if you have 2 atoms attached, it will always be linear. So this is just chlorine bonded to chlorine. The very, very last one, water. Water, we know, is H2O. 2 hydrogens mean 2 electrons. Oxygen, there's 6, so that's a total of 8. In this case, oxygen will go in the middle with its valence electrons. So I'm just placing them. So 1, 2, 3, 4, 5, 6. Add in those hydrogens. Describing your central atom, it's an AX2E2 shape. So we have the oxygen being the A, hydrogens being the X2, and then we have 2 lone pairs, so that's why we have E2. It will give you that bent shape, and when you go to draw it, oxygen's in the middle. Because the lone pairs affect the shape, we do want to draw it in. So we'll have one bond going to the lone pairs, another bond going to the lone pairs, and then showing that 3D shape within the page, out of the page, 2 more hydrogens. So this is where we get that bent or V shape. As always, I hope you found this helpful. If you did, please subscribe. And if there's any other video you would like me to do for you, please leave me a comment. Thanks for watching.